Hello everyone. I told you about the standby timing of Intel's 500 series chipsets in the last lesson. Through measurements, we found that almost all standby voltages are supply bridges. So in this lesson, let's talk about the power-on timing of the 500 series chipset. Almost all the power of the necklace timing is supplied to the CPU. So we first find the CPU power supply module in the catalog, on pages 6 and 7 of the drawings. We can see inside the CPU, in addition to the core power supply, can be external. There are also many auxiliary power supplies. Which of these power supplies was generated first? We should know. The first thing that comes up is VCC DDR. That is, the main power supply of the inner layer. Here we have already told you. It is 1.2. This voltage is in the point map, including in the circuit diagram. They are all very easy to find. In this position, after we directly power on, test here. 1.2. But, however, DDR4 memory will have a 1.2 power supply. It will also have a 2.5. So when everyone is measuring, don't forget this 2.5 voltage. Although this voltage of 2.5 will not be supplied to the CPU, but it feeds the memory stick. Let's take a look at other voltages. Below, we should be able to see that there will be a signal to maintain the voltage. It's called VCCST. And VCCST machine, it has two. This test point, it should be on top of the two inductors here. Here is the VCCST machine. Here is VCCST. The voltage of both of them is the same. All are 1.5. 1.5. 1.5. In addition to this signal maintaining voltage, we can also see there will be Vecchio here. And there are two channels, Vecchio 0 and Vecchio. Vecchio power supply. So this one, we should be able to measure this inductance and this inductance. This side is 0, this side is 1. Attention everyone, I am now measuring all these voltages without the CPU. 1.0, 1.8. ONOV. There is a slight difference between these two forces. The next one we should test is VEXA. VEXA we can use the dot bit map. See testing at this place. 1.5. In the end, what remains is the core power supply. WIC. There are a total of 14 core power supplies on the normal version. That means 14 inductors provide power to the CPU. So how many volts is this voltage? Now it is in a state where there is no CPU up. What I measured was the bot voltage. 1.5. The last one is VCCGT. VCCGT is generated only after the polar is detected. But now, because it is in a microboot state, we can also measure it. Its voltage is currently the same as the core voltage. This is under the state of no CPU installed. So when these are normal, we can measure the clock. This is a fixed test point, at 13 of 14. Clock voltage 0.40 nV. Let's test it again. The negative position is not. What does it mean? The description is below the state of no CPU installed. We cannot measure the negative voltage. Let's install the CPU. After installing the CPU, let's call again. Measure its timing. See what changes it has. The inner layer is mainly powered. 1.2 unchanged. 2.5 unchanged. VCCST remains unchanged. FTG remains unchanged. Let's take a look at VSIO. 0.9ev. Let's look at another one. There is no voltage. What does this mean? Explain the voltage of VEXIO. It is to be generated according to the load on the CPU. If the CPU is relatively low-end, it only produces one VEXIO. If the CPU is high-end, or if the load is heavy, it will produce two VEXIOs. Let's take a look at VEXA. 1.5 of unchanged. Core power supply. 1.0. Then let's take a look at VX7. At this time, there is none. Why? Now it's on the CPU. Okay, let's take a look at this clock again. Normally, let's take a look at the reset. It's normal. It means that this board must be on the CPU before it can generate a reset signal. And after installing the CPU, the power supply of VEXIO will change. In addition, the power supply of VX7 will also change. Alright, today's video is shared here. Thank you for watching.